distributive properties here. So I'm going to show two different techniques. They both will work in any case, so you can just choose which one you kind of like the best, which one is most efficient for you. For the left example, I'll draw in the arrows for all the pieces that I have to multiply. So first I'll take that 2a and multiply it against all of the pieces of the second trinomial. So 2a times 7a would be 14a squared. 2a times negative 2b would be negative 4ab. And then 2a times 3 is 6a. Then I'll come with the 3b and do those ones against all those other pieces. So 3b times 7a would be 21ab. 21ab. 3b times negative 2b would be negative 6b squared. And then 3b times 3 would be 9b's. So there are 9b's. Then I'll take that last number, the minus 5, and multiply it against all three of the other pieces. See why the colors are getting a little useful here, but with pencil you'd have to be very careful. Negative 5 times 7a would be negative 35a. Negative 5 times negative 2b would be plusing 10b. And then minus 5 times 3 means there's a minus 15 at the end. So the final answer to this problem would be 14a squared. Let's see, negative 4 plus 21 would be 17ab's. 6 minus 35 means we'd have negative 29a's. A minus 6b squared. 9b and 10b is 19b, and then subtracted by 15. So there is the product. Okay, that's way number one. Way number two is to set it up in a grid-like fashion. So maybe 5x, 2y, minus 3 being multiplied by the binomial x minus 2. And then, bringing these into a little chart type form, we can organize all of our information inside of a chart using the row and the column as the products. So 5x times x would be 5x squared. X times 2y would be 2xy. There's a minus 3x. Here's going to be a minus 10x from the 5 times the negative 2. Looks like a negative 4y. And then we have negative 2 times negative 3, and that's just going to be a positive 6. So what do we have all together? Well, looks like we have a 5x squared from here. We have a 2xy from here. There's two places with x's. We have negative 10x and minus 3x, so that'd be a total of minus 13x's. Then you just have a minus 4y and a positive 6. So that would be the final answer for this one. The right hand side isn't always easier. This one just had less pieces. So why don't you try this one on your own by whichever means you would prefer. Assuming you paused the video and tried it on your own, I'm going to do this in a chart form using the chart going longer or taller than it was longer, so you can see how the method doesn't really matter. So we have a y minus 3, two things across the top, 2z minus y, 3 down the column. So creating the chart and filling it in, 2z times y would be 2yz. Then here's a negative 6z. Here's a minus y squared. Here's a 3y. I don't need to put that plus, I don't know why I did. But there's another 3y here anyway. And get there a minus 9. So as a final answer on this problem, we would want to see 2yz minus 6z minus y squared. I'm going to combine those together because they're like terms and put a 6y. 3y and 3y together is 6y when we're adding. And then minus a 9 on the end.